talking about divisibility rules, those are going to come in really handy whenever we're talking about prime factorization. And that's what we're going to talk about for this video. And the two methods in which we'll be doing that are factor trees and the ladder method. I do think that the divisibility rules for 2, 3, 5, and 10 are incredibly relevant for this, and they are a mega time saver. So just know that if any number ends in 0, 2, 4, 6, or 8, you can always divide by 2. If you add the digits together, for example, 12, 1 plus 2 is 3. 3 fits into 3 evenly, so that would be divisible by 3. If the digits end in 0 or 5, it's divisible by 5, and if they end in 0, they're divisible by 10. These are things that are going to constantly come up. And what about whenever we're talking about factoring and factor trees and ladders? Well, a tree is a very common way to break down a number into its prime factors. So let's talk about the word prime. Prime is whenever you have a number that is no longer divisible by anything other than itself. For example, 3. 3 is the only number that fits into 3 as well as 1. So the only factors that make that number what it is, the only numbers you can multiply to get it are 1 times 3. That's what makes it prime. 7 is another example, 5, 11, 13, 17, 19, 23. The list goes on and on and on. There is no way to multiply by any two whole numbers to get that other than by 1 in itself. So let's just take a simple example of a factor tree with 40. Okay, and I'm going to do the ladder with 40 too, but I want to go ahead and just emphasize the tree first. So thinking of our divisibility rules. All right, so far we got a number that ends in 0. So that's divisible by 2 because that ends in 0, 2, 4, 6, or 8. It is not divisible by 3 because 4 plus 0 is 4, and 3 does not fit evenly into 4. It's divisible by 5 because it ends in 0 or 5, so that means we could divide it by 5. It ends in 0, so that means it's also divisible by 10, so that means we could divide it by 10. Let's go ahead and just, for the sake of going like, it's an even number, so let's go by 2. 2 times what? 2 times 20, okay? Is 2 a prime number? Is there anything that you can multiply 2 by other than 1 to get 2? The answer is no, and whenever you reach a prime factor, you circle it, okay? Now we're dealing with 20. We know that that ends in 0, so 0, 2, 4, 6, or 8, divisible by 2. Ends in 5 or 0, divisible by 5. Ends in 0, divisible by 10. Let's do 10. 2 times 10. 2 is a prime number, so we're circling it. And now you can see we got to break down 10. It ends in 0, so let's just divide it by 2. 2 times 5. And you now have all of the prime factors of the number 40. So what this means is if you did 2 times 2, you'd get 4. And then multiply by 2 again, you get 8. Then 8 times 5 is 40. This is as much as you can break down the number 40. And a way to rewrite these prime factors would be 2 to the third power times 5. And if you want to write 5 to the first, you can. Whenever you have just a 5, it automatically has an exponent of 1 because there's only one 5 to multiply by. So this would be considered a final answer. The ladder, very simply put, it could follow the same process. Let's go ahead and just go by 5 on this one. Let's use different factors. It ends in 0, so that means I could do it by 10. All right, so I'm just going to go ahead. 10, so that simplifies. 40 divided by 10 is 4. And then we talk about what goes into 4. Well, 0, 2, 4, 6, or 8, so that means it's divisible by 2. So 4 divided by 2 is 2. Okay? This is where you're going to get more of the same thing. This would be where it gets narrowed down to its smallest number. This could be broken down into 2 and 5. And then you have the 2, 2, 2, and 5. I prefer the factor tree. The factor tree makes it to where you don't have to think about anything. It gets it down to its prime factors the fastest, in my opinion, and it has the most absolute answer. So whenever we're talking about trees and ladders, I prefer to use the ladder whenever it comes to, say, 25, like we're dealing with a fraction. Let's say 25 over 40. Now, if we want to deal with two numbers, a ladder is a good way to do it, 25 and 40. We know that numbers that end in 5 or 0 are divisible by 5. Okay, so now we do 25 divided by 5 and 40 divided by 5. 25 divided by 5 is 5. 40 divided by 5 is 8. Okay, and nothing can simplify 5 and 8. There's nothing that goes into both of them. So I think it lends itself to simplifying fractions. There is no common factor, so 5/8 is the simplified version of 25/40. Now, that would be a little more difficult to do and be a lot more work for a factor tree, but I think that's where I see the ladder coming in. So uh, whenever we go over this in tutoring, this is the basic idea. We're going to be going into more depth, most definitely.